Okay, YouTube Nation, shout out Miss Rhiannon Farr.
All right, so it is finals week, so that means stress upon stress upon stress. Yay. But you guys got it. You guys do great, and just hit me up on Twitter. Okay, bye.
You have a gift for radio. So, here's the deal. What I thought was really cool about math when I was growing up was that if I could learn something that I didn't know how to do and learn how to do it really efficiently. So, for example, if you look at the first question, 1 over x plus 2, a lot of you would have no idea what that looks like. And the fact is, we're going to learn how to sketch these today. We're going to learn how to sketch them, and we're going to learn how to sketch them extremely efficiently and quickly. So when you look at these, it's not a question like, oh boy, I have no idea what that looks like unless I plug it in my calculator to all of a sudden be like, yeah, I got it, no problem. All right? So it all starts with being able to identify the parent function. The parent function for the first one is y is equal to 1 over x. And you remember that what we did on Friday, we talked about, I'm sorry, this was actually Thursday, I think. Oh, no, it wasn't. We didn't do those, did we? Oh, we got to back up real quick. Take out your notes. No, we didn't. Take out your notes. We missed this. That's right. We had our evacuation, didn't we? Oh, boy. Ooh. Yeah, it's going to look like... There we go. Okay. All of these you have to have committed to memory. Suppose you have y is equal to a constant. Say y is equal to 4. You know that that's a horizontal line. Suppose you have y equals mx plus b. That will be a line with a slope and a y-intercept. Absolute value. Y is equal to absolute value of x. Right? We won't do the greatest integer function. It's really not worth it. Power functions, y is equal to x squared. It's parabola. You're familiar with all of these, right? Y is equal to x to the third. Y is equal to x to the fourth. You think it'll look like x squared or x to the third? X squared. Just a little bit more narrow. I'd show you something cool with that, but we really don't have time for that. So y is equal to x to the fifth. Going to look like x to the third, just, again, more narrow, steeper. So nothing too surprising yet, right? Root functions, like y is equal to the square root of x. Is that shape? Can you take the square root of negatives? That's why you don't have anything over on the left-hand side. But can you take the cubed root of negatives? Yes, you can. So therefore, you have stuff on the left-hand side. The fourth root of x, or x to the 1/4. Note that you can always write these with a rational exponent or as a radical. You think that'll look like the square root or the cubed root? Square root. And then y is equal to the fifth root of x. You know, that's, again, going to look very similar to the cubed root. So the cubed root one is kind of new, right? But that's really the only one that's really new so far. So not too bad. Other root functions. This is my favorite one. Y is equal to x to the 2/3, or the cubed root of x squared. So can I square negative numbers? And when you square it, it will become positive, and then you'll take the cubed root, and you'll come up with a positive, right? So this one looks like this. Somebody say it. Looks like a bird. Yeah, everybody. I call it the bird function. Yeah, so cool. All right. All right. So y is equal x to the 3/2. Well, now that's a little bit different, and here's why. Um, 3/2 is like 1.5, correct? So it's not going to be as steep as a parabola, and it's not going to be as flat as a line. It will actually be somewhere in between. So it, just kind of heads up like that. But it doesn't have any negative values. Why? Because it can't take square root of a negative. So there's any negative values. And now we come to the last set of functions that are possibly the most important for you to learn during the course of pre-calculus and calculus, and that is the reciprocal functions. Y is equal to 1/x. And we have to understand how this function is generated. We're going to plug in x values, and that will generate y values for us. So suppose you plug in 6 for x. What would y be? 1/6. Plug in 5. 4. 3. 2. Half. 1 is 1. And then what if we plug in a half? What's 1/2? 2. 1/3. And you can see what's happening here. And it gets infinitely close to the y-axis and to the x-axis, but never actually crosses it. If you plugged in negative numbers, you would get that. And so this has a special line. It is a vertical line called an asymptote. It also has a horizontal line that's an asymptote. Asymptote is a line that the graph approaches as it heads on off towards infinity. Okay. So it approaches that line. You can pronounce it asymptote, which is probably the more common way. I pronounce it asymptote. It's a Greek word, and yeah. So anyway, yeah. So you would never say asymptote in Greek. You'd say asymptote. Exactly. So mathematical idiots. All right. So then we do this. Okay. So y is equal to 1/x squared. Let's think about y equals 1/x squared. Well, how's that going to be different than the first one? What happens to negative values as we plug it in? They become positive. Well, hey, I think I know what this is going to do. It's going to look a lot like the first one. It's just going to be positive. And then if you think about it, 1/x to the 3rd would look like 1/x. 1/x to the 4th would look like 1/x squared. 1/x to the 5th. 1/x to 6th. You kind of see how those are going to take similar shape. Now, obviously, the higher degree, the more stretched it will be. But that's a little bit of the idea. So, what do you think? Yeah. So what we did on Friday with the other classes, we actually covered all these pieces to talk about the different shifts and transformations. But that's kind of what we did on Friday together, wasn't it? So for example, we did x squared minus 3. That's going to shift it. Yeah, let's just do these real quick together, okay? Square root of x minus 4. Tell me, what do I do? 4 to the right. Plus 3 minus 2. What? Very good. Next one. Good. Whoa. Silly. Let's do the 4 on the bottom. Negative root of x. Uh-oh. Like that. Because it's a vertical flip. The parent function looked like that, so it was a vertical flip. Well, now that I have you thinking. Cool. Okay, now we get to 3 that are a little bit more difficult. 3 minus the x squared. I want to encourage you, and for those listening here, there's true mathematicians. You might hate what I'm doing right now. I apologize, but honestly, the best way to go through these is do what I do. So this 3 minus the x squared, you might think of it as negative x plus 3 quantity squared. So you might say, well, move to the left 3 and then do a horizontal reflection. I think that there's a much easier and better way to make it through these kind of problems. You want to hear it? What number do you plug in to make 0? 3. So you move it right 3. Square it out. Will the x be positive or negative? Positive. So we'll go up or down? Up. Watch, 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 watch. Yo. Uh-oh. You see, because you see the plus 3, right? So technically, here's what it wants to do. It wants to move to the left 3 and then do a horizontal reflection. But to me, horizontal reflections are a pain in the butt. The only time I really like to think about horizontal reflections is when we're doing square root functions. That's the only time. Or I really can't stand them. So what I do instead is I do stuff like this, okay? Watch. What do you plug in to get 0? 1. So it moves right 1, moves up 4. And then when we cube this out and we attach a negative in front, will it start down and go up or start up and go down? Start up and go down because it will be negative. I just think that's a lot easier. What do you plug in to get 0? 5. So it moves to the right 5. And then there's a negative on the outside, so that will make it, yeah, go down. So that's how I handle the horizontal reflection piece if you were to see it. So let's go back to our worksheet that we were working on right here. So this is a parent function of 1 over x. And you remember that that's what it looks like if we look at our parent function sheet. But we have a shift here. The plus 2 is on the inside. If you look at this one down here, the plus 3 is on the outside. So this is on the inside, so I'll move to the left or to the right. The left 2. So that will take the vertical asymptote and move it to the left 2 units. Does it move up or down at all? No. So the horizontal asymptote will stay at 0. Now, this may look like a complicated graph. At the end of the day, we graph it pretty quickly. And we're actually very accurate. If we were to type this in our calculator, we'd be spot on. Now, an easy way to write the domain is all numbers not equal to what? What can x not be equal to? -2. And the range, y cannot be equal to what? I challenge you to come up with a number to plug in for x that would give you 0 for an answer. It will not happen, okay? -2, 1 over 0, undefined. You will not pass go. You will not collect $200. Okay, x minus 3 to 1/3 power. That's a cubed root function. Who remembers what cubed root looks like? Oh, Terry does. What is it? Yeah, all right. So this will shift what? 3 to the right. Domain, all real numbers. Range, all real numbers. Okay, the third one, parent function. What do you got? Good try, not quite. It's a reciprocal function, but it's squared, right? So, well, they both either want to be above or below. So you saw from what we graphed before that the 1 over x squared, that they look like this, okay? So the x minus 3 will move it 3 to the right. There's no vertical shift. But now here's where you got to pay attention. We have a negative and we have a 2. What do you think the negative does? Yes, it'll create a vertical flip. So instead of them both being above the x-axis, they'll both be below. Now the 2 simply creates a vertical stretch. It's just, kind of like a line. Slope of 2 as it compares to slope of 1. You don't have to try to show that. It doesn't show up very well with these type of curves. So if this was a 4, you'd graph it just the same. I mean, we're not going to be able to really show the difference. We're trying to show a quick, accurate sketch. That's what the graph will look like. If you're not convinced that that's accurate, that that's what it looks like, again, try it on your calculator. Domain, x not equal to what? 3. And the range from -infinity to 0, parenthesis. This next one, what do you plug in to get 0? 4. So it moves right 4. Up 1. Will it head off to the right or to the left? Which is it? Why does it head off to the left? The negative is in front of the x. That creates a horizontal reflection. Always be careful with the square root functions. That's the one where it's hard to figure out the horizontal reflection. Okay. Domain. Domain -infinity to 4, range from 1 to infinity. Sometime you might want to rewrite the function. So y is equal to -x minus 2 to the 5th plus 4. Might help you understand better how to graph it. So a 5th degree polynomial will look like what other one? The 3rd degree, exactly. So what is our shifts here? What are our transformations? And then a vertical flip. Let's go like that. Well, hi there. Domain, all real numbers. Range, all real numbers. What's different about the next one compared to the others we've done? Yeah, this +3 will create a vertical shift, so the horizontal asymptote will move up. So there's no horizontal shift, so our asymptote vertically will stay the same, but now instead of a horizontal asymptote at 0, that will be shifted up to 3. Is there any vertical reflection here? Nope. So domain x not equal to 0, range y not equal to 3. We're going to do 3 more together. How about the next one? 1 over x squared would make them both in the same region, but this is odd to the 5th power. So that means you're going to have 1 in the bottom, 1 in the top, or 1 in the top, 1 in the bottom, right? Okay. So it wants to look like this. That's what it wants to look like. And we know that because it's odd. If it was even, then it would be like this, okay? So if it's even, they'd be like that, but it's odd, so they're going to be in the opposite. But what are the shifts that we have for the translations? Right, 3. And then a vertical reflection, yes. Domain, x not equal to. And range, y not equal to 0. 4th root, what's a 4th root going to look like? Yep, look like a square root. So I'll draw the parent function. We'd head off just like that. Everything's on the inside here. What would you plug in to make 0? -3. So it will move to the left 3 units. That's what we got. Domain. And then range 0 to infinity. Let's do one more. Flip it over. I want to do my favorite one. This is the same as -x to the 2/3 plus 4. Same thing, okay? Now, do you remember what that parent function looks like? The bird. Okay. We go up 4. It's upside down, right? Domain. Looks like all real numbers. And range. -infinity to 4. Again, every once in a while, you might kind of worry about, am I really sketching this well? And, I think it's pretty cool to just punch in a calculator every once in a while and see what you get. If you type this in, the cubed root of x squared, and, you can even bold the parent function if you want. You can even set your window so it's a 6 by 6. And you press graph. I think we've done a pretty good job at graphing this. Wouldn't you agree? That's pretty much exactly what we have. So you might say, well, how accurate is this? It's pretty darn accurate because we're the best. We are the best. Okay. All right. There you go. That's your assignment. Go. No assignment tomorrow. Just work on your study guide.